Hello and good day everyone. In the last video, I've shown you how to create an ALU with adder and subtractor in Circuitverse using XOR and gates. In this video, I'm going to show you how to use and configure the ALU that is already provided for by Circuitverse in one of its circuit elements. It is called the ALU also. Now, I think it's found in the circuit elements under miscellaneous. Now you have a symbol there like this. This is the arithmetic logic unit of the Circuitverse. Let us drag this over to our circuit board and try to configure this. Now, unlike our ALU, which only does addition or subtraction, this ALU has several functions. In fact, it has 7 functions. It can do an AND, it can do an OR, it can do a plus, it can do an AND with a NOT, it can also do an AND OR with a NOT, and it can also do a subtraction like ours, and it can also do a comparison whether A is lesser than B or not. Okay, so if you look at this configuration, there are 3 main inputs. We have control A and B, and there are 2 main outputs which have the answer and the last carry. The last carry is a 1-bit output, which will signify the last output, the last carry of the last full adder that was included in the ALU. Now let us try a simple example by using single bit inputs and single bit outputs. To do that, we'll have a single input for A, we'll have a single input for B. We can have a single output for our carry, which we will point upwards. And we'll have a single output for our answer. Okay. Take note at this point that without the control signals, the ALU is useless and will not do anything. So in order for this to function, we'll have to increase or include an input to its control, or CTRL. No? This is control. And when you connect this, an error is issued that there's a bit width error between 1 and 3 because we have provided a 1-bit input to the control signal, which expects 3 bits. So we'll just click on our input and extend this to 3 bits. Now we have a 3-bit input and the error is gone. It had an error when it was 2, but now it's 3, it's gone. So let's do a simple addition. For addition to be done, the control should be 0, 1, 0. In which case, if you have 1 plus 0 is 1 carry 0, 1 plus 1 is 0 carry 1. Okay? And subtraction is 1, 1, 0. If you do that, 1 minus 1 is 0. Okay? And we can also check whether A is lesser than B. For example, we'll do a 1, 1, 1. So this is a 0 because 1 is greater than B. But if we'll change this to 0, it's still a 0. But if we'll change B to 1, this now becomes a 1 because A is lesser than B. Okay. So one more problem with this is if you have more than 1-bit input, the 1 will be carried as the least significant bit. Okay. For example, if we will have a 2-bit input, for example, we'll extend our ALU to 2 bits. Okay, and then we will extend this to 2 bits. Also to 2 bits. We still have an error because our output should also be 2 bits. Okay. So in this case, if you'll say 3 plus 2, okay, shall we say 2 plus this a plus 0, 1, 0. Yes, this is a plus. Yes, 3 plus 2 is 5, and that cannot be represented anymore. So for example, we have 2 plus 1, that's 3. Okay, but if you'll have 2 and 1, and we'll set this to 1 1 1. Okay, this is 0 0 because 2 is greater than 1. But if we'll set this to the other side, now what we have here is 0 is lesser than 2, so therefore it will have a 1, but we cannot have access to the least significant bit, which is 1. That's one main problem. Okay, to have access to these bits, we have to use a component called the splitter. For the moment, let us delete the output and replace it with a splitter. It's in the miscellaneous uh, section of the circuit elements. We'll click this. We are going to split our output into two. So therefore, we're going to click the splitter and the bit width of 4. And then we just disregard the bit width split because we are not going to split. I'm sorry, this is not a bit width of 4, but a bit width of 2. So our bit width is 2, and then we'll split it. Okay, so now we have access to the individual bits. Okay, so for example, we have output of x, and then we'll have another output to the least significant bit. So this is now our least significant bit, which we have output. So we can configure the ALU by controlling the input, which we can also split. In this case, we can also individually split the input. Let's delete this. And instead of that, we'll use a three-way splitter by the bit width to be entered as 3. Can we just press escape? Now we have this as 3. Okay. And maybe we can set this down. So the reverse. This is the reverse. Can we set this to right? Okay. Or just set this to left like that. But this time we will change our okay. We will change our input. So this will be our input. Okay, this will be our second input. We'll put this down. And this will be our third input, which we will put down. Advantage is with this is we can have an individual access to this, so that we can fix one byte to be 0 or maybe fix another byte to be 1. Remember, how do we fix this? For example, to do addition always. Okay, to do addition always, we can connect constants. For example, we know that addition is 1 0 1 0, so we can connect a 0 to this, and then we can connect a 0 to this, and we can connect this is 1. Okay, so this is 1, so this will always do addition. Okay, we can also fix this to do a comparison always by placing this or adding this with connecting this to all ones. There are many ways to configure, and in summary, that's how we can control the ALU provided by Circuitverse. By splitting the input, we can configure the individual bits. By splitting the output, we can have access to the individual bits. I hope you got the point, because in our next video, we are going to create a 4-bit ALU, this time using the ALU provided by Circuitverse. Thanks for watching and see you then.